Good morning, everyone. I hope I'm audible to all of you and my screen is visible. Yes, I hope I'm audible to you and my screen is visible. Okay, all right. So, I have received some queries in terms of for certain PYQs from all of you. So, I will first take that up. I'm going to first discuss a few queries or questions that I have received, and then maybe we will discuss a few topics, in consumer behavior. Okay. Yes, Avanti. I'll definitely take up this question also. Just let me just do a few questions a few queries that I have received till now from PYQs, and then maybe we will definitely look at your doubt also. Okay. Yeah. So, one of the questions, or this is actually one of the PYQs which I had received as a doubt, and the question says that write down, or I'll just open that question for you. I don't know who sent it, but I believe most of you must have tried this question, which talks about presenting the Slutsky equation in terms of elasticity. Have you all seen that question? Which talks about, which discusses about describe the Slutsky equation in elasticity form. I'll read out the exact question for you, just to, just to clarify. Right? The question says, write down Slutsky equation in elasticity form. And then in the next part of the question, it says, prove that ordinary demand curve will have greater elasticity than compensated demand curve for a normal commodity. And how does your result change when the commodity becomes inferior? Okay, this is a question from 2019. Have you all seen this question? Yes. Have you all seen this question? Which talks about writing down Slutsky equation in elasticity form. Okay, so let's just understand how we can write Slutsky equation in elasticity form. Okay, that's the first thing that we can discuss. Right, so simply, I can first write my Slutsky equation. Right, I hope you all remember that in case of Slutsky equation, basically we are talking about, breaking up the price effect into income effect and substitution effect. Okay, so we can write it like this, that we can say that if total price effect is given as change in quantity of x due to change in price of x, that will be a sum of the substitution effect and income effect. Okay, now I can write substitution effect like this. This is total change in quantity due to change in price. I can write substitution effect like this, delta xc upon delta px. Please understand, here C stands for the compensating change that we are making, so that the consumer comes back to, or the consumer is able to afford his original consumption bundle. Okay. Aditi is asking, ma'am, I am getting confused in Slutsky equation, theorem and identity. What to write in it? Simply see, Slutsky theorem talks about this only, that, if there is a price change for a consumer, then he should be compensated in such a way such that he is able to afford his original consumption bucket. Okay, right? And you can explain the entire explanation theoretically, draw the diagram that we had done in the class, right? That diagram of when there is a fall in price. Okay, you can write that, draw that diagram, and then you can write the equation. The equation is given as it is in variant, Aditi, right? We had also discussed it in class, that how we can present the substitution effect and income effect as and sum them together to get the price effect. That's the Slutsky equation. Okay, right? Simply, this is what I'm writing here also. That this delta xc upon delta px. What is it showing us? It is showing us the change that we are making in the your demand, or it is showing us the change in quantity demanded due to change in price after the consumer has been compensated in such a way that he is able to afford his original consumption bundle. Right, remember that CD budget line that we were drawing, which was passing through the original consumption bundle, which was reflecting that consumer is being compensated to come back to his original consumption bundle. Okay, that's the effect that we are talking about here. And then income effect we had written like this: delta x upon delta m into x. Okay, this also we have done in class. Remember the explanation from variant, right? We had written it like this. Okay, is this second equation clear to us or not? Why we have a negative sign here, that also you should remember. We had discussed that real income effect and the real income effect and the nominal income effect are exactly inverse of each other. Just the sign changes, magnitude remains the same. That is why the minus sign here. Okay. Ma'am, when do we write the rate of change Slutsky equation? If it is asked, Aditi, that is just one way of presenting the that is just one way of presenting the Slutsky equation. If the question demands you to write it in that form, you can write it in that form. Otherwise, the standard equation. Okay. Okay. Now, this is the equation that we have for Slutsky, right, which shows us that total price effect is equal to the sum of substitution effect and income effect. Right? But we want to present this equation in elasticity form. Right? So just because the question is demanding us to present it in elasticity form, we will somewhere change the way of writing this. Okay, we will have to make some alterations in this equation. Right? So what I will do is that I will first multiply both LHS and RHS by Px upon x. Right? I will first multiply both LHS and RHS by Px upon x. Right? So let us do that. I'll get delta x by delta Px into Px upon x equals delta xc by delta Px into Px upon x minus delta x by delta m, right? And this is multiplied 2x into px upon x. Okay, this is what I'm getting when I'm multiplying both LHS and RHS by px upon x. Okay, next what I'll do is that I will multiply this last term, this last term on the right hand side by m upon m. Okay, what I'm doing is I am multiplying last term on RHS by m upon m. Again, does this change the meaning of the equation? No. Right? Numerator and denominator are same, so it does not change the meaning of the equation. Right? So I'll rewrite it for you. We can write it like this: delta x by delta px into px upon x equals delta xc by delta px into px upon x, right, minus x times delta x by delta m into px upon x multiplied by m upon m. Okay, we are multiplying this last term with m upon m. Now what I'll do is that I'll just simply rearrange a few things in this, right? I'm not changing the meaning here whatsoever. I'm just simply rearranging a few things here. What I'll do is I'll write this px into x upon m as one term, right? So I'm writing it like this: px right? Px into x upon m is one of the terms that I have. Then I'll write this part, the remaining things together. So I'm left with delta x by delta m into m upon x. Right? I'm left with this delta x by delta m into m upon x. And remaining terms are as it is. Okay, this is as it is, this is as it is. Okay. Now tell me, what does this represent? Delta x by delta px into px upon x. You would say, ma'am, this looks like price elasticity of demand, right? So I can write it as, let's say, ED, right, which is price elasticity of demand. Now I have delta xc by delta px into px upon x. What does this represent? Ma'am, this represents the price elasticity of demand of that CD, or basically this is showing us that when consumer was shifting from the original bundle to the compensated bundle, right, then what is the change in price elasticity? So you can say that, ma'am, this represents price elasticity of demand of the compensated function, or you can say it represents compensated price elasticity of demand. Again, please don't confuse it with the Hicks compensated demand curve. We are not talking about Hicksian curve. We are talking about the Slutsky compensated curve here. Okay, then a minus sign. Then what is this? Px into x upon m. What is this showing us? This is showing us the share of expenditure on good x out of the total income, right? So let me write it like this: share of expenditure on good x from the total income multiplied by delta x by delta m into m by x. What is this showing us? Income elasticity of demand. Okay, so I'll write it like this. This is showing us income elasticity of demand for good X. Okay, so this is how you can present your Slutsky equation in terms of price elasticity, or this is the elasticity form of the Slutsky equation. Okay, this is the elasticity form of the Slutsky equation. Yes, I hope this part is clear to everyone. I hope this part is clear to everyone. Any doubt in this? Okay. Now see, the question asks, prove that ordinary demand curve will have greater demand elasticity than compensated demand curve for a normal commodity. Okay. So what is this ED? This is basically elasticity of the ordinary demand curve. And what is this elasticity of demand of the compensated demand curve? This EDC is the elasticity of demand of the compensated demand curve. And what is this? This is elasticity of demand with respect to income. Now understand, this is in general form. If let's say this is a normal good, we can clearly see that how are we arriving at elasticity of ordinary demand curve. Elasticity of ordinary demand curve here is given as uh, some kind of you can say this entire elasticity of compensated demand curve minus some share in income and the elasticity of demand with respect to money, right? So here you can clearly see that we are obtaining this equation by subtracting some amount here from this. Okay, so certainly you should know that elasticity of ordinary demand curve in this case will be greater than the compensated demand curve. Okay, or again sometimes in certain kind of questions or equations you would say that, ma'am, why are you writing the nominal income elasticity of demand? Instead you can write here the real elasticity of demand with respect to income. In that case our equation will become like this: ed equals edc, right, plus share of good X in income, right, plus your EDC. elasticity of demand with respect to real income, which we used to write as N. Okay, and in a note you can mention that elasticity of demand with respect to nominal income is the negative of the elasticity of demand with respect to real income. In bracket you can show this, right? So you will get something like this. There's no plus sign here, they're multiplied to each other. Okay, so you get share of income of good X in share of good X in the total income multiplied by the elasticity of good X with respect to real income. Now you can clearly see from here that when you are adding something to the compensated elasticity, you are arriving at ordinary elasticity. That means clearly see that ED will be greater than the compensated elasticity. Okay, and that's what the question is asking. Question is saying that show that elasticity of the ordinary demand function or of the ordinary demand curve will be greater than the elasticity of the compensated demand curve. Okay, so is this part clear to us why it is greater? Yes, is this part clear to us? In case of normal goods, okay, in case of normal goods this would be positive, right? So that is why this ED will be greater than the elasticity of compensated demand function. Okay. Now suppose we have a case of an inferior good, right? And again I'll rewrite the equation for you. I have ED, right, which is the sum of compensated elasticity, right, multiplied by the share of good X in total income into elasticity of demand for good X with respect to real income. Okay, so now if I talk about the case of an inferior good, right? In case of an inferior good, we know that the elasticity with respect to money demand is always negative. Elasticity of demand with respect to income is negative in case of an inferior good, right? So definitely then this entire term would become negative, right? And if this becomes negative, from here we will obtain the result that elasticity of demand for ordinary demand will be less than the elasticity of demand for the compensated demand curve. Okay, elasticity of demand for ordinary demand curve will be less than elasticity of demand for the compensated demand curve. Okay, that's it. That's how we are supposed to prove this part in the question, that why elasticity would be different for ordinary and compensated demand curves in case of normal goods and inferior goods. Okay, I hope this part is clear to everyone. Which part, Aditi? The second part? See, simply, I'm again rewriting the same equation, that total elasticity of demand for ordinary function is equal to sum of the demand for compensated demand curve plus share of income of good X, share of good X in total income multiplied by elasticity of demand with respect to income. Now, in case of inferior good, this is going to be negative. Okay, when this is going to be negative, then definitely this compensated demand would be greater than ordinary demand. Okay, ma'am, is the last term END this? Yeah. Okay, elasticity of demand with respect to real income. Because see, Aditi, ideally, when we are writing this simple kind of equation, we are, making use of the real income effect, right? If you remember, the first time when I had written the Slutsky equation, I had not written it in terms of ordinary or nominal income effect. We had also written it in terms of real income effect. Okay, that's why logically or in terms of sign, right, the plus and negative signs, they would work in the correct manner if you make use of this kind of an equation. Okay. Remember the first time when we studied Slutsky equation, we had written it in terms of substitution effect and real income effect only, and not nominal income effect. वो तो जब when we did rates of change, at that time we introduced nominal income effect. Otherwise, we have always been writing the equation in terms of substitution effect, real income. Okay. Yes, I hope now it is clear. What about others? Is this question clear or not? Any doubt you can ask me. Okay. If is there any doubt in any part or any equation? Okay. See again, such kind of questions, may or may not be asked again in the exam. Sometimes we have seen repetition also. You never know that certain times, same kind of questions are put up in the exam. Okay, but maybe what they can do is they can just tweak the question a little bit. That uh, um, what would be the case in case of a given good or some other kind of minor changes they can make, but still they can again ask the same question, that write the Slutsky equation in elasticity form. That is quite possible. Okay, ma'am, if income effect is negative, then shouldn't ED be greater than EDC? So no, basically we are saying that we here we are going to get some negative sign. Okay, right? See, if I'm writing this kind of an equation, when I'm adding something to this, then I'm arriving at this. It means that ED is greater than EDC in this case. Okay, yeah. See, only difference here is that in case of inferior goods, okay, I'll just if you go back to the case of inferior goods, let's say price is decreasing. Okay, when price is decreasing, your purchasing power is increasing, right? And when purchasing power is increasing, then in that case, your uh, uh, demand for an inferior good would also decrease. Okay, right? In case of uh, in case of your inferior goods, when price falls, your purchasing power increases, and despite the increase in purchasing power, the demand for those goods decreases. Okay, so when we see the real income effect, we compare this, and that's why we say that it is negative. Okay, so here, of course, then we are going to get a negative sign. Okay, right? Right? Okay. There was one more question that was asked, there was one more question which said that there is a demand curve like this: Q equals to A P to the power alpha y to the power beta, right? Where P is price and Y is income. Okay, where P is price and Y is income, right? And then the question says that what is the meaning of alpha, right? So here, what is alpha? Alpha is basically price elasticity of demand. How can we prove that it is price elasticity of demand? We simply calculate ED for this kind of a function. So ED, right, with respect to price will be given as dq by dp, right? Or in fact, you should be writing del q by del p. Del q by del p into p by q. right? So del Q by del P, if you do that, you will get A alpha P to the power alpha minus 1 into Y to the power beta multiplied by P, and this is divided by Q. So I'll rewrite Q again here. I'll get A P to the power alpha Y to the power beta. Okay. Okay. So when you will solve this kind of a question, you will see that eventually you are just left with alpha. So it means alpha is price elasticity of demand. Okay. Right. Then, yes, Aditi, just give me a moment. Let me finish this question and then I will take up your doubt. Okay. So here alpha is price elasticity of demand. Similarly, the question said prove that beta is income elasticity. What is the meaning of beta? Right. So you can simply understand that beta will be income elasticity of demand. You can prove it also. You can rewrite the demand function Q equals to A P to the power alpha Y to the power beta. Just find out elasticity of demand with respect to income now. So that would be del Q upon income is represented as Y here, right? Del Q by del Y into Y upon Q. When you will solve for this, you will arrive at beta. Okay, so beta here represents the income elasticity of demand. ठीक है? Right? I hope this part is clear. This question is also clear to everyone. Yes, I hope this question is clear to everyone now. Yes, what about others? This question is clear now. Okay. All right. Let me just quickly now go to first the question that Avanti had asked. In exam, which is better to use the simple price elasticity formula or midpoint method? Depends on the type of the question, Avanti. Uh, Definitely in different questions, depending upon the demand of the question, you will have to choose that which formula you are going to use. Okay. So again, there is no set pattern for this. Okay. In certain cases, midpoint formula would be working. In certain cases, your price elasticity formula would be working. Okay. Then, do we have to study the theorems in Engel curve and income elasticity? Engel curve, we have studied in class. Whatever portion that I have covered in class for Engel curve, that is sufficient for you. That is what you have to cover. Okay. Theorems, can you specifically mention which theorems you're talking about? And maybe then I can tell you whether you have to refer to it or not. Okay. Yes. Then, Avanti, you're asking, how did we know that exactly price and income elasticity is to be calculated? You should get a hint from the example of constant elasticity of demand. Remember, Avanti, that in case of constant elasticity of demand, constant elasticity demand curve, right? The demand curve was something like this: Q equals to A times P to the power elasticity. So always remember, any exponent attached to price for a demand function will be the price elasticity of demand. Similarly, any exponent attached to income will always be the income elasticity of demand. Okay, that is the hint. From there, we understand that this will be price elasticity and this is income elasticity. Okay, yes. What does alpha and beta mean? Simply understand that in case of alpha and beta, you are summing up price elasticity of demand and income elasticity of demand. That should give you total price effect. See, you are calculating only change in quantity demanded due to change in price, keeping income constant. And then in the second part, you are calculating change in quantity due to change in income, keeping price constant. What is that? Substitution effect plus income effect, which is equal to price effect. Okay? Yes, Aditi? So alpha plus beta would be total price effect then, right? Avanti is asking theorem in H.L. Ahuja under income elasticity heading. Uh, okay. Avanti, what we can do is maybe at the end of towards the end of the class, I will just open up the textbook and you can tell me which specific topic you're talking about. Okay? Yes? Okay. There was one more question. State and prove Slutsky theorem and then derive demand for Giffen good using this theorem. To derive demand Giffen good demand curve, should we use diagram or should we use equation itself? Use diagram, Aditi. That's the simplest way, and the examiner will give you marks if you explain it through a diagram also. You don't necessarily have to give an algebraic explanation every time. No. Okay. Okay. I hope these doubts are resolved now. Yes, I hope there is no doubt in this part. Yes. There was one more question which I had received as a doubt, and I'll pick that up also. Ma'am, but it said use the equation itself, then diagram isn't required. Aditi, you will have to take a call depending upon the weightage of the question. If it's a long answer type of a question somewhere in section C, right, then you can draw the diagram also. Okay, don't leave any possibility that examiner might cut your marks just because you have not drawn the diagram. Amanju? Right, so if it's a short answer question where you are done with the word limit, then don't draw the diagram. But if it's a question somewhere in section C, then draw the diagram also. Okay, I hope that is clear. Yes. Okay. Then there was one more question. Again, first I'll read out the question for you. It says, define the method of compensating variation of income and method of cost difference. Right? It says, the question says, define the method of compensating variation, right? That is CV, versus the method of cost difference, right? Versus the method of cost difference. Okay. And then in the second part, it asks, why is the latter method superior to the former one? Okay. So if you must have read the chapter from H.L. Ahuja, right, there is an appendix that is given which talks about the Slutsky substitution effect. And over there it says that Slutsky substitution effect method is also called as cost difference. Okay. So cost difference is same as Slutsky substitution effect. Okay. Cost difference method is same as the Slutsky substitution effect method. Okay, first things first, this should be clear, right? Now, are these two same? I want to ask this first, that is compensating variation same as Slutsky substitution effect? If yes, why? And if no, why? You have to tell me. Is compensating variation same as cost difference? Is compensating variation same as Slutsky substitution effect? No. Okay. And what's the difference? Well, you can just type your answer and I'll open up a slide for you. Okay, in one we keep utility constant and in the other one we keep purchasing power constant. ठीक है, ठीक है. Yes. So again, your explanation is apt that in one the purchasing power is kept constant and in the other one the utility is kept constant. Okay, let me just present one slide for you so that it will become much more clearer to you. Yes. Can you see my screen? Is the PPT visible? Yes. Is the PPT visible to all of you? Yes. I hope you all can see the PPT. Yes. Okay. All right. So, see in the question, they are asking us to compare the method of cost difference versus compensating variation. Okay. And you should first understand that cost difference is same as Slutsky substitution effect. Okay. Now I have drawn these, I have taken these two diagrams of Slutsky substitution effect and compensating variation, both in case of rise in price. Okay, rise in price. Okay, let's first look at Slutsky substitution effect. Right, you can see here in this diagram that I'll zoom it for you a little bit. Yeah. See, in this case, you can see clearly that let's say my original budget line is this PL. Okay, this is my original budget line. Now, with this PL budget line, my optimum quantity is this at point Q. Okay. Now, suppose there is a rise in price, and when there is a rise in price of good X, the budget line will change to, let's say, PL dash. Okay. Now, due to this, the new or the final consumption bundle for the consumer will be here at point R. Now, suppose we want to distinguish between Slutsky substitution effect and income effect. What will we do? You will say that, ma'am, compensate the consumer in such a way such that he is able to afford his original consumption bundle. That is, you would say that, ma'am, draw another hypothetical budget line which should pass through the original consumption bundle of the consumer. See? So for that, we have drawn this budget line GH, which is parallel to your PL dash and it is passing through the original consumption bundle Q. Okay? Right? So this is, so the movement you can say from, if you want to compare the substitution effect, then you would say that my original consumption bundle was this Q. Now the optimal consumption bundle at this new GH budget line is this S. It is not Q because Q is not tangent here. Q is not at tangency. Okay, the new point at tangency is point S. So difference between Q and S, right? This Km basically is showing me the substitution effect. Okay, this difference K and M is showing me the substitution effect. Okay, yes, I hope this part is clear. The Slutsky substitution effect for a rise in price. Yes, any doubt in this? Please ask. Yes, I hope this part is clear to everyone. Yes, what about others? I hope this diagram, we have already done this diagram, but way back. It's been 6-7 classes back, maybe when we did this diagram, just revising it. So K2M is the cost difference. Absolutely, Sudipta. Okay, basically you will say that if you remember, right, we had taken that example from Varian where we had a demand function for milk, remember? And in that we had to find out delta M, and that delta M was given as delta P into X, right? So basically this is your cost difference. Remember? Yes? Right. Now let's look at your let's look at the compensating variation diagram. Okay, let's look at the compensating variation diagram. Now, in this, my original budget line is this gray budget line, right? This one. This is the original budget line. Okay. Now, at this original budget line, what is the optimal bundle? You will say that, ma'am, the initial optimal bundle is this X1 star, X2 star. This is the optimal bundle. Now, suppose there is a rise in price of good X. When there is a rise in price, the budget line changes and it comes to this point, this budget line. Okay, this one. Okay. Now, when there is a change in price or when the consumer's price is rising, definitely, in order to calculate compensating variation, we will ask that how much income should be given to the consumer at the new prices such that he reaches the same level of utility which he had at the original prices. I repeat again, in case of compensating variation, if you remember, we would say that how much money income should be given to the consumer so that he reaches the same level of utility that he had at the original prices. So you would say that, ma'am, shift the final budget line parallelly in such a way so that it is tangent to the original indifference curve, this one. Shift the new budget line parallelly in such a way so that it is tangent to the original indifference curve. See, now it is tangent here at this point. This is the new optimal bundle at the new prices. Okay. So, what is the change in income then here? This was the budget line after the price change, and this is the budget line that we have drawn to compensate the consumer. So this gap between these 2 points is representing what? It is representing compensating variation. Are these two the same? No. In Slutsky substitution effect, we had drawn the budget line passing through the original point of consumption or the original bundle. Whereas in case of your compensating variation, we are drawing the budget line or the compensated budget line which is tangent to the original indifference curve. Okay. So simply what you have to do in this kind of a question is, in the first part, draw these two diagrams, write an explanation for them. That solves the first part for you. Okay. Again, please make sure that in both cases you are taking the same example. If you're talking about price fall, then both diagrams should be for price fall only. ऐसा नहीं कि एक में price rise बता दिया, एक में price fall बता दिया. On the other hand, if you're talking about price rise, you will take price rise in both cost difference and compensating variation. Okay. Yes, I hope this is clear. Yes, I hope this part is clear. Okay. Yes, what about others? I hope this part is clear to others also. Okay. Now, in the second part of the question, it asks why is the latter method superior to the former one? It is saying why cost difference method is superior to the compensating variation method. Simply, it is superior to the compensating variation method is because you are able to decide with certainty how much income you are required to give to the consumer to compensate him so that he reaches his original bundle. However, in case of compensating variation, you want the consumer to reach his original level of utility. And somewhere utility in itself is a very subjective concept, and it is not easy for us to find out that okay, this much income should be given so that consumer reaches his original level of utility. That's the only reason why this method is superior. Okay, you can read this explanation here. Slutsky method, yeah, method of cost difference has a distinct advantage that it is easier to find out the amount of income that equal to the cost difference by which income of the consumer has to be adjusted. On the other hand, it is not so easy to know the compensating variation in income, right? Because the concept of utility in itself is difficult to measure, it's difficult to understand. That is why, with certainty you can find out that okay, X was my original bundle, this is the change in price, so this is the income that I have to give. But if my utility was at some level, it's tough to find out how much income should be given. Okay. Also, you can write one more point that cost difference method has the advantage of being dependent on observable data. While for knowing the amount of compensating variation, knowledge of indifference curve about tastes and preferences, etc. of the consumer is required, which is always subjective and which is always tough to obtain in a real life kind of a situation. Okay. Yes, I hope this explanation is clear to everyone. Okay, you will find this in H.L. Ahuja. Just read the appendix today. You will find this explanation over there. Okay. Yes, I hope this doubt is also clear. These were some of the questions that I had received from the academics team, which you had sent as doubts to them. I hope it is clear now. Ma'am, is this explanation similar to that of Higgs substitution effect where there is no income effect and hence this is inferior method? No, we don't say that there is no income effect as such in case of Higgs substitution effect. No. You are mixing substitution effect with income effect now, Aditi. That will confuse you even further. Don't mix those two explanations. ठीक है? Yes. Chal. So let's come back to the topics that we were discussing yesterday. I hope there are no other doubts left in what you had sent to the academics team. Also, Aditi, I had evaluated that answer. That is correct. I have also responded to the academics team. Maybe they will send the response to you. That answer is correct. Any other query sent by you which has not been resolved till now? I believe I have taken up almost most of the questions that were sent as queries. Can I attempt questions from G1 from PYQs and send them to you as doubts? You can help me. Nikhil, only send those questions in which you have doubts, okay? Where you're finding the solution and you think that, okay, this is the right answer, then don't send that. I mean, there's no point me giving marks to you for those kind of questions. For that, you're already having weekly tests. In any doubts that you have, definitely send them to the academics team and then I will discuss them in class. Others have already started doing that. You can also send them. Okay, but just have a specific doubt that okay, in this question, this is the part that I'm not able to solve, then we can take that up in class. Or otherwise, you can post it in the chat box here, in the comment box here. We will take that. Okay. All right. Okay. Let's come back to our concept of elasticity again. Right. Again, in elasticity, there is one more way of presenting the elasticity form, and that is in the form of log. Okay, sometimes it might be asked to us that express elasticity in log form, right? So we can quickly discuss elasticity in log form. Okay, so first of all, it can be written like this: d ln q by d ln p. This is price elasticity of demand. Please understand this price elasticity of demand. This is showing us change in quantity due to percentage change in quantity due to percentage change in price. Okay. Now, question is that, ma'am, how or why? How do you think this is representing, elasticity of demand? Okay. So for this, we can just make some minor changes. Okay, to clear it out or to explain it. See, we can write d ln q by d ln p like this. We can write it like this: d ln q by dq into dq by d ln p. I've not done anything. I've just multiplied this entire expression by dq upon dq. So I've written d ln q by dq into dq by d ln p. Now what is this? D by dq, first derivative of the log function. Right? So if you remember, d by dx of log x is given as 1 by x. So here I will write 1 by q. I hope you are understanding this part, why I am writing d ln q by dq or d by dq of ln q as 1 by q. Yes, I hope you are understanding this part can be written like this. Yes, okay, and multiplied by dq upon d ln p. Okay. Now there is one, so this is one result that I have got. Okay. Now I can say that my slope or dq by dp of a function can be written as dq by d ln p into d ln p by dp. I've done nothing. I'm just trying to explain that dq by dp can be written as I've just multiplied it by d ln p in numerator and denominator. So dq by d ln p into d ln p by dp is what I have written. So here, this I can write as it is dq by d ln p, and d by dp of ln p or d by dp of log p will give me 1 by p. This is dq by dp. Okay, right. So from here, I'm getting an formula or I'm getting an expression for this. I can write dq by d ln p as equal to dq by dp. I'm just taking this p on this side into p. Okay, dq by dp into p. Now let's go back to our first equation. I have 1 by q into dq by d ln p, and now for dq by d ln p, I have an expression. Right? So right, from 1, I can write, I'll rewrite the equation of 1 for you. dq by d ln p is given as d ln q by d ln p. We had written 1 by q into dq by d ln p. So I'm just substituting the value of this over here. So I get 1 by q into dq by dp into p. Right? So from here, I get dq by dp into p by q. Right? Which means that this is, what is this equal to? Price elasticity of demand. Which means that I can write price elasticity of demand as this also, d ln q upon d ln p. Right? It's just showing us that I can write price elasticity of demand as d ln q by d ln p. Yes, I hope this part is clear to us. Any doubt in this? Yes, I hope this part is clear to us. Yeah. Okay. One more topic or one more small explanation, right? And I want you to read a few parts today regarding this from the book. I'm just giving a simple explanation right now, and then once you read that chapter or that appendix part, then of course, things will be more clearer to you. We can also discuss them in the next class. But simply, I'm talking about the concept of Lagrange optimization. Right? What is Lagrange optimization? Lagrange optimization basically is a method to find out consumer equilibrium. If you remember, till now we were finding out consumer equilibrium using the approach that mu of x upon mu of y is equal to px upon py at the point of equilibrium. Right? This is a formula that we had been using till now. Now, Lagrange optimization also provides a solution to find out the equilibrium of the consumer when his utility or his preferences are given to us and his budget constraint is given to us. Right? So, for this function, for this Lagrange optimization, we first of all create a Lagrange function. Okay, so let's say you have a utility function which is given as, which is a function of two goods x and y, and you have a budget constraint which looks like this: m equals to px into x plus py into y. Right? So how will you write the Lagrange function? You can write the Lagrange function like this. Right? You can write it as Lagrange function is equal to the utility function plus lambda bracket your budget constant, that is m minus px into x minus py into y. This is what we call as the Lagrange function. This is a standard form of a Lagrange function. Why are we making this function? Because we want to find out consumer equilibrium. Please understand, in the Lagrange function, there are always two components. There is always an objective function, right? And what is the objective function? Objective function is the function which is to be optimized. In our case, what do we want to optimize? We want to optimize utility. We basically want to maximize the utility of the consumer, right? So the function that you want to optimize is called as the objective function. In our case, it is the utility function. And the second part of the function is called as the constraint function, right? So in case of a consumer, what is the constraint? The constraint is the budget. Okay, so the consumer always wants to maximize his utility subject to the budget constraint. So in this case also, we have to maximize or we have to optimize the objective function subject to this constraint function. Okay, right? So this is the constraint. Also, this number lambda here, right? This lambda here is the Lagrange multiplier. This lambda here is the Lagrange multiplier. Okay, and I will tell you, we will discuss what is the implication of this or what is the meaning of this Lagrange multiplier. But first, just try to understand that what is or how do we present a Lagrange function, how a Lagrange function looks like is what we are trying to understand from here. Is this function clear? Are the parts of this function clear to everyone? Yes. Is this function clear? Are the parts of this function clear to everyone? Yes. All right. We'll stop here today. There's much more to do in Lagrange function. It is going to take some time for us, right? A little bit more explanation. Then we'll also look at a numerical to solve any kind of utility maximization problem through Lagrange. Okay, so we will discuss that tomorrow. What you can do is that in your HL Ahuja book, there is an appendix which talks about the Lagrange optimization. Read that appendix today. It's given in very simple language. It's just a pre-read for you. Of course, whatever is given in that chapter, we are going to discuss in class tomorrow. But if you go through that, you will just have a quick idea of, what I'm trying to explain. Okay. And it's not a very big topic. I think 3-4 pages, not more than that. Just go through that topic so that, you are clear with some theoretical portion of Lagrange optimization, and that we will cover them in tomorrow's class. Okay. Yes. Any further questions before we close the lecture? Yes. Any further questions before we close the class for the day? Any further questions? No? Okay, then I'll stop here today. I'll see you all again at 7:30 tomorrow, and then we will start with the explanation of the Lagrange optimization method, and also we will look at one PYQ related to this. Okay? All right. Thank you everyone for joining today.